What we're going to do in this section is do the error bounds. There was one other section, oh, sweet, I do have some, where we found error. We maximized it and then got a window for our sums. Remember, geometric series, if they converge, we can get it exactly. Telescoping, if it converges, we can get it exactly. Almost all the other ones, all we can do is simply determine whether they do or don't converge. But there was one other series, do you remember which one it was, where we could not get it exactly, but we could say, well, here's a window. The integral test, yeah, what we did for the integral test, don't write this down, is we took what was left, like we'd say use the first 5 sums or whatever, so you would do S of 5 and you would write it all down for 5 terms, and then we'd say, don't write this down. There's a remainder after those 5 terms, and what we said about that remainder for the integral test is that we knew that it was at least less than the integral. I'm going to soon put f of x dx, because this is adding up all real numbers, whereas the series is just doing integer values. So you can be 100% positive that the most off you could be would be that certain amount. So then we said that we knew we had like a neighborhood for our sum, and it was actually really a very constricting neighborhood. Like it was off usually only like to the thousandth place. So it's a good estimate, but we said that it's either going to be here or this plus that remainder. And that was less than or equal, we'd put that in there. And this was for the integral test. But the reason it was always positive is for that integral test, it had 3 criteria that it had to meet. The function had to be positive. What else? Increasing. And so the increasing part of it made it that, okay, it can never be below S of 5. So it put that part as the lower bound. But alternating series is a little different because those alternate between positive and negative. It's not an always increasing function. So there's a little bit more thought to figuring out what our error is. And I'm going to show you it working. I could, again, just go to the next page, and here's the theorem, I guess you'd call it, for how you set up your window, but I'm a little worried that you wouldn't quite get what this is saying. So I'm going to show it to you with a concrete alternating convergent series. So I'm going to put a basic one down here. Let's consider. So we're going to explore it first, and then I'll show you, and it's a really easy thing to do. The matter will just be, can you remember it? Because there's lots of stuff to remember in this chapter. So we're going to consider the sum and going from 1 to infinity, and we're going to alternate 1 over n squared. So we're going to put an alternator in there. I want to make sure it starts positive, so I got to be careful when I put my alternator in, because I can't do negative 1 to the n, because then I'll start off at negative. So I'm going to adjust that. What am I going to put as my exponent so I can start at 1 and not negative 1? N plus 1. So you adjust with the alternating series. Sometimes you have to fart around with where to start your alternator depending on whether the first term is positive or negative, but this will do it for me. Right now, by the way, I would say that this function for sure converges, right? What's your alternating series test? Just to review, because it's been a couple days and you guys did it by a limit. The minute you see this trigger, an alternator in with a series, you take a limit. So let's go like this, off to the side. It doesn't, you're not going to need to do this in the bottom part today, but I'm going to just run through the alternating series test. The limit as n approaches infinity, when in the absence of the alternator, is 0. Normally, though, I stressed it a zillion times in the notes, normally when you run this nth term limit on here and you get 0, you cannot say it converges. We're done doing that, right? Right? So when the limit of 1 over n squared equals 0, the only time you can say it converges is when it's in the presence of an alternator. Because what's happening is enough is being subtracted to cause that. So you would say, therefore, this, let's call this S. S converges by the alternating series test. If I were to ask the question, does it converge absolutely? Or does it converge conditionally? You won't be asked that on the AP exam. Next year's bunch will, but you guys won't. But it's an easy test. Do you remember how you decide if it's converging, what we say, absolutely or conditionally? There, exactly. I remove the alternator and I just look at the series without the alternator. This series, in the absence of the alternator, doesn't even need that minus every other term to make it converge. That right there is convergent by itself. Why? Again, I'm just doing a little review here, but how do I know that converges? Yeah, it's a P series. P greater than 1, like you guys are getting good at it. So we would say, therefore, because in the absence of the alternator, it converged anyway, we say it's absolutely convergent. Again, that's not, I just wanted to review from Wednesday, I guess it would be. So now I'm going to write this out so you can see what's going to happen with the value of the sum. So let's go write S. And let's start listing it out for a little bit. When I put in a 1, it's going to start out as 1 over 1. When I put in a 2, my alternator is going to go to an odd term, so it's going to be a minus, and it'd be 1 over 2 squared. Then it's going to be plus 1 over 3 squared, minus 1 over 4 squared, plus 1 over 5 squared, minus, and it's going to alternate. And I'm going to keep going for a little bit because I want you to see what's going to happen with this. And I'm just going to go like that. That is S. Do I know exactly what its value is? No, but I'm going to get really close. So what I'm going to do is they'll tell you to use a certain partial sum for your estimation. We're going to look at S sub 4. All right, so S sub 4 would be what I get when I add up those first 4 terms. So if you could go get me a value for that, that'd be helpful. Either just manually brute force work it out, like a 1 minus 1/4 plus 1/9 minus 1/16. Or if you wanted to do your math 0 from 1 to 4, that would be helpful. But if you could, I don't think I had a calculator when I put this, I didn't. So if you could give me a decimal for that. Take out your calculators. You guys got to help me out. What is it? Can someone else back that? Because I don't want to have a wrong number. So do 1 minus 1/4 plus 1/9 minus 1/16. And let's go point. What do we got? 7, 9, 8. Let's keep going. 6, 1, 1, 1. Sometimes you'll see these get stored. They don't always, because we're doing error bounding, you keep them more accurate. I know you're used to rounding to 3 decimal places. You might say, well, what about on the AP exam? They don't cover this topic. We're on an extra, we're enrichment today. It's enrichment day. Next year, I'll have to cover this in detail. Last year and this year, it's just because. So what I have here is I've got S sub 4. What I want you to do now is we're going to look at the rest of this. So right here, which is what I'd call R sub 4, the remainder after the first 4. I do know that S sub 4 plus R sub 4 has to equal S, right? So what I'm going to do is bound that with something, and I'm going to rewrite these terms a little bit. Up above, I'm going to write this as 1 over 25 minus, and then I'm going to go like this, 1/36 minus 1/49. And you can agree with me, if I distribute this negative in, you can see that that is the exact same numerical amount. And I'm going to do the same with the next one. I'm going to make it minus 1/64 minus, it'd be 1/81. If I'm going to do a little strategic grouping here so you can see what's going to happen. Right here, is that chunk, that underlined piece, positive or negative? Positive. So I'm subtracting a positive amount and more positive amount, right? And I could keep on going to infinity and I'd be subtracting more and more and more. So what that does is it gives me a bound for the rest of that because I know it has to be under what? 1/25th. Excellent. And that's what the alternating series remainder says. It says the most off you can be has to be less than or equal to your first unused term, which they call A sub n plus 1. Does that make sense? So this right here is the most off I can be. So I'm going to write this. My remainder after 4 terms has got to be less than or equal to 1/25th, which is what on the next page they call a sub n plus 1. But I want you in your head, because thinking of it with notation isn't very good. I have a student who's with me in the morning, and he had me for Calc 2 last year. I said, do you remember this? He goes, oh yeah, it's always less than the first unused term. So if you think of it in a sentence and not a sub n plus 1s, it's better. So write this first, and that should be absolute value, to be honest. First, unused term. So I can get a window. This is what I know about my sum. My sum has to live in a certain viewing window. I can even be more precise than what's required, but this is a minimum amount of precision that you need. The lowest it could be, because again, this is alternating, so I can't assume that the function's always increasing, but the most it can do is go down by this much or up by this much. So if I were to write it with the numbers, I'd say S sub 4 minus 1/25th is the lowest it could be. S sub 4 plus 1/25th is the highest it can be. And that's my, what we call error bound. If you could go to your calculator though, can you get me some numbers for this? Because I do want to run a test so you can see it. So if you could take this S sub 4 and subtract 1/25th, somebody with a calculator, you've got one, Jake. And then if somebody else could take that same S sub 4 and add 1/25th, Mitch, I think you've got one. I want to get a pretty, you'll see what a constricting window it is. And I only went out to 4. You know what I mean? Had I used S sub 80 as my partial sum, that would have been even better. Do you have one for me?
Yeah.
So, okay, I'll steal that. So you did the minus? Yep. So 0.75861 repeated. And does somebody have the plus for me? Did you do it? Perfect. I can't read yours. 0.83861 repeated. Now what I'm going to have you do is use your math 0 and just test this out. Go take and do S sub 99 using math 0, and you'll see it fall in that viewing window. So go do S sub 99 just so you can see it working out, and it will be in that viewing window. And then I'm going to tell you about how if you really get it, you can even constrict that some more. I won't make you constrict it, but we can even get that down a little bit if we outsmart the alternating series remainder test. Did anyone run that through quickly with your math 0 on the original one? And you have to put the alternator in there. What'd you get? Okay, so here's the thing. Doesn't this seem like it's kind of a big span? Do you see how I'm closer to the top bound? Here's why. Really, because I know this next term is a plus, I know I'm actually never going to be lower than S sub 4. I could have constricted this a little more for this one. If you know the sign of the first unused term, you can really narrow it down even farther. I could have had, I know it's not going to go below 0.798611, really, because the first unused term is going to be bumping it up, not down. Does that make sense? But that's the LaRude refinement on the alternating series remainder. It actually says your window is your partial sum plus or minus the first unused term. So it seems pretty easy, doesn't it? Let's go take a look at another one. So this is what I just told you. I'm not going to reread it. That's it if you were to look it up. If you were to consult the Google, the intranets, the World Wide Web, that's what it would say for alternating series remainder. I wouldn't bother reading it. But what do you think this is their notation for, just having just sat in here for 2 minutes? That's the what. A sub n sub 1 is really the what in my language. First unused term. Okay, it's really, we take the absolute value of it, but we are entirely sure that our error is under that. So what we're going to do is go try one. It'll tell you what to use. This would be called the sixth partial sum. You can do that on your calculator, so this is very calculator active. So if you could go get me S sub 6 first. Might as well get that in there because that's going to be kind of our anchor for this problem. And then we are going to go up and down from S sub 6 to create a window of accuracy. Then I have one more to do and we're done. I told you the alternating series test is a kind of a wimpy one. And I'll get a couple backers on this if you guys can tell me what that is. Factorial. 0.63194 repeated. It seems to be. Okay, so let's write that down. 0.63194 repeated. Now, in order for me to find out my error, I do need to brute force write these out. So I need to write them out so I can see the 7th term. So technically I don't, but I want to write them out so we're going to refine our window a little bit. So let's go write this down. When I put in a 1, this is going to start at -1 to the 0, which is 1, over 1 factorial, which is 1. Then it'll be minus, because a 2 will make that. It'll be 1 over 2 factorial. Then it'll be plus 1 over 3 factorial, minus 1 over 4 factorial, plus 1 over 5 factorial, minus 1 over 6 factorial. I'm going to quit writing the numbers out. And then it's going to be plus 1 over 7 factorial, blah, 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 blah. All right, that S sub 6 is what this stuff adds up to. My first unused term is a bound for my error. Is my error going to be going up or down? Up, because that's plus. So although if you were to look in a textbook, it's going to say this. S has to live in S sub 6 minus 1 over 7 factorial, S sub 6 plus 1 over 7 factorial. I would argue that and that's what you can put on a test. That's what I put on your worksheet. But I'd argue if we're really outsmarting it, what could I put as my lower bound? Just S sub 6 and I'll have a better viewing window. By the way, had this been a minus right here, then my top can just be S sub 6 because I know I'm going to be going down more than I'm going up. The reason they don't put that in the theorem is because what if it's S sub 82 that they're using as their partial sum? Do you want to write 82 of them out? And then, you know what I mean? So they do make a larger viewing window than is necessary. Let's get some numbers for this, if you will, please. Give me some numbers for S sub 6. So if someone can just enter 0.63194 repeated minus 1 over 7 factorial. And then I'll steal somebody, if the same two, maybe Jake and Mitch, if one of you, are you doing the minus? You're doing the plus. Will you do the minus then? You're getting both. Ah, sweet. This one is? That seems large. This minus 1 over, because 1 over 7 factorial is incredibly small. Oh, I was going to say, oh, perfect. 0.63174, 0.632. Why do you think this viewing window, because having a gut instinct in this chapter is so helpful. Why do you think this window of error is so much tighter than the other one? The factorial in there, yeah, it's causing it to converge so quickly. I actually couldn't have you go test S of 99 because most calculators bug out on factorial. You could try it, like if you tried to math zero that and go to 99 like I did on the other one, I think your calculator is just going to kind of go screw this, and it can't, that 99 factorial, it just can't even go there. So anyway, this is what I call a viewing window. I am 100% sure that the actual sum, I'm now accurate, by the way, to the hundredths, because the next question is on get me a certain accuracy. So this one says, we want you to make sure you're approximating that to an error that is no more than 1/1000th. There's a lot of error bounds that are done, by the way, in engineering and stuff because they want to make sure their machines like work within a certain, you know what I mean? You can only allow a certain margin of error for a lot of things. I want to make sure that whatever I use, I don't err by more than 1/1000th. So watch how this works. I'm going to use this phrase again, it works by brute force. You really need your first unused term, because that's what our error is. Go ahead and write that. First unused term of your partial sum, which you don't know how far you have to get out. We have to kind of create that. I want my first unused term to be less than or equal to 0.001. And then I can create a window that's accurate to that. decimal place. So what I'm going to do is I'm going to start writing S out. I'm going to go put a 1 in there and realize it's going to start at positive 1 over 1 to the 4th. Then it's going to go 1 over 2 to the 4th plus 1 over 3 to the 4th. And I'm going to go a ways here, and you guys are going to help me out because I don't know how far out I've got to go. That's the deal. I have no clue. Let's see if this is good enough to stop, though. Somebody do 1 divided by 4 to the 4th. What did I do? Oh, a minus. Yep, sorry. I didn't alternate. Which is kind of important with an alternating series that you remember to alternate. Can somebody do that for me? Because I know 1/81st isn't enough because that's less than 0.01. Ah, that's too big. Okay, so 1 over 5 to the 4th. Can somebody do that? This is what I call brute force. You just got to go try it until you get a winner. What's 1 over 5 to the 4th? I'll steal that. Thank you for being my calculator today. 0.0016, which I'll just round to 0.002, so still not good enough. So minus 1 over 6 to the 4th. I'm thinking this will be my winner. What'd you get for that one? 0.0002. It was 2, by the way, it's for those of you who forgot your scientific notation, it had an E negative 4, so I have 0.000. Oh, yeah, I read the bottom one. Sorry, he went farther out. Yep, so it's 0.0007, so it'll be an 8 technically because it was 7, 7. That's my winner. What that means is this. I need to do the 5th partial sum. Okay, so what I need you guys to do is, it says approximate the sum. I'm going to get a window for it. Okay, and I'll say it lives in this window. It's approximately somewhere in here. I'm going to use the 5th partial sum. So you guys are going to go tally that up for me. And we'll take it out to a few decimal places. Thank you, Mitch. Enter that for me. That's why I said I need calculator help, because notes take twice as long if I'm going and entering all those on the smartboard. You'd want to shoot me. It's very awkward. Do you have that one for me? All right. He's got 0.9. Did anyone else do it? Okay, did you get 0.947? Okay, perfect. I just want to put a, not that I don't trust you, Mitch, but I always need a backer. Good enough. Let's go out that far. Remember, we're only going to analyze it out to 3 decimal places, out to the thousandths. So there's my S sub 5. My error is at most that, right? So here's my viewing window. My error, my sum is going to live in. Now let's even refine this a little more. Because that is the first unused term, I really don't need to do which one. Go up that for the top or down that for the bottom. Up that for the top. I know that because this first unused term is negative, this actually can serve as my top boundary. Technically, if you look in the back of the book, though, they will add that on because technically it says go up, go down. So again, Tomes, if you want to go up and go down, give me the full viewing window. But I know on this one, I really only need to go down by that. So can you subtract that from this? I don't know what it is. 0.9467 All right, so now let's run a test here. I am 100% sure that my sum, regardless of what it is, falls within that viewing window and is no more than 0.0001 off. And you can see this. Do you see at this 0.0001? And it's less than that. So do we have to test it? I think we're good. So we're going to quit here. Your assignment is going to be, you're going to take that worksheet if you tried and you guessed at it. You're going to erase all that stuff at the bottom. Your assignment from last time was 1 through 9. You're going to do 10 through 12. You can turn that in today. And then take out your big packet. And I'll tell you what you can do right now because I have that written down. So your big 2A packet, there's been stuff I've said you have to do. And I'm going to tell you what you can do. I wrote it somewhere here. Okay, so you can now be done with basically all of 1 through 4 should be done. And 5, you can do most of that. But, yep, yep, you bet. I'll just go. You can do 5 K, L, M, N. K, L, M, N, and number 6. 5 K, L, and there's more in there you can do. Oh, you can do all of it up to there, but I mean about today's stuff. Yeah, the ratio test you cannot do, and that's I and J, so you can't do those. You could do K, you can do L. You kind of know, don't you? Like when you look through it on the first pages, if it says ratio test, don't touch it. But there's even more, like there's a direct comparison with M. N says any method, but go look at 5N. Who's your method of choice? Probably the alternating series test. Number 6 we just did today, so you should probably tackle that one. And then I'd almost wait on 7 through 15 because we have 2 more tests, unless one stands out to you for sure. Let's talk about that, and then I'll be done. 7 through 15. Does number 7, are you 100% sure you know how to do that one? Number 7. Yes, then do it. Number 8, are you 100% sure? Yes, then do it. Number 9, you might be kind of iffy on, and that actually is going to be a ratio test, so I would wait. So you kind of know. Number 11 is going to be a ratio test. So get as far, I would just get through 5M or whatever. We'll be done. I do want you to finish the AST. I posted the key for that so you can check your, I did the big viewing window. I went up and down for all of them because that's, again, you're not even expected to have been exposed to this section, so